Hello and welcome back to app development. So this is where we're going to do the second half of the app. All right. You've already designed the interface. Now we're actually going to write the code that's going to drive that interface so that it actually performs like a calculator. All right. So hopefully you're familiar with this site at this point. You're going to go to the MIT App Inventor site. You're going to go to Create Apps. You're going to log into your account. And you want to bring up the calculator that you worked on last time. So here's the calculator. I've already fired up my emulator, so you don't have to sit here and wait for it to start up. Again, just a reminder, don't start the emulator until you've finished the design work. If you try to start it before then, it's likely to crash, and then you're going to have to restart it anyway. So do all the design work first, and then fire it up. And then it should be good to go when you start writing the code, because you're going to want to test your code. You don't want to try to write the whole program and then see if it works. You write a little bit of code, you test it. You write a little bit of code, you test it. That way, if something doesn't work, you know exactly what's not working. It's not like, oh, is it this thing that I did, or is it that thing, or is it the thing that I did 10 minutes ago? You do it in tiny little bits and check it as you go to make sure that it's as quick as possible. Now, one thing I want to note as we're going through the code, do notice just that how I've named my things here. So I named my table arrangement keypad. My buttons are num1, num2, num3, plus, minus, mult, equal, CLR, div. The text label where the output is, I call display. The reason I'm just pointing that out is that if you gave it different names, if you gave those things different names, when I start doing the code, you might not see display on your screen. You might still see label 1 if you didn't rename it. So you just have to realize that on my screen, it's going to say display because that's what I named it. If you chose a different name or you didn't rename it, yours might still say label 1 when we get to that part of the code, and you just have to realize that those are talking about the same thing. All right, so to do the code, we're going to switch over to the blocks here. And we've kind of talked about this already, but MIT App Inventor is an event-driven programming language, which means that when your program starts up, nothing really happens. Like, all right, I launched my emulator. Here it is. But the program is just kind of sitting there and waiting for something to happen. All right, that's what I mean by event-driven. And when something happens, then we're going to execute some block of code. So it's going to be a lot of, when we're writing this code, setting up events or things that the program needs to detect. And then once it detects those things, writing the code that goes along with that. All right, so that's kind of what I mean by event-driven. So first things first, like, what are events that we might deal with? So with this calculator, the most basic event is going to be when somebody clicks on a button. All right, so each button has its own event. And when we click on that button, we're going to want different code to run, because we don't want the same code to run when you hit the plus button as we do when you hit the minus button or when you hit the 8 key or the equal key. So we're going to be setting up code that triggers based on which button you've hit. All right, so that's kind of the first thing. The events are generally associated with the objects. So up here where it says built in, these are the blocks that you can use inside of the events. All right, if you want an if statement, which we'll talk about later, if you want logic, if you want math and calculations, if you want text, all right, these are all blocks that are going to go inside of the events. When you start clicking down on your objects here, and again, these are all the objects we added to our app, this is where you're going to start seeing the events. The events are usually these yellow blocks, and they're pretty self-explanatory. about what they are. So, for example, when I click on this num1, I can see one of the events is when that button is clicked. There's also got focus, long click. So if you do a long click, you could have different code run than if you do a short click. Touch down, touch up. So these are all events that the app inventor software or language can detect. And then inside of these events, we're going to write whatever code we want to have happen. Below the events are a bunch of green blocks. All right, and these are the properties of that object. So when we were in the designer view and we added a button, there were all these properties we could change. All right, we could change the size, the font, whatever, and we could change those in this design window. We can also change those things when we're coding. So these dark green blocks that say set let us change the properties. So if we wanted our code to change the background color, we could do that. If we wanted our code to change the font size, we could do that. If we wanted our code to change whether or not it was visible, all right, we could do that. So the dark green blocks let you change it. The light green blocks let you know the current value. So if for some reason in your code you needed to know what the font size was, this block would give you that information. The dark green blocks let you change the information. The light green blocks let you know what it is. And if you accidentally ever drop a block over here, you can always just throw it in the trash can and delete it and get rid of it that way. You can zoom in, you can zoom out. So that's kind of the general frame here. And then this is just telling me that my screen is empty, and am I sure I want that? So I am. So let's talk about our calculator here. So when you're using a calculator, there's certain information that needs to be stored or remembered. All right. So if you think about a very simple calculation, all right, let's say I'm doing 7 plus 3. All right. Now, if I was on the calculator, what I would do is I would click the 7. Then I would click the plus sign. Then I would click the 3. All right, I would click those 3 buttons. Now, as I'm clicking them, the program needs to remember what I've clicked. Because I click the 7, then I go over here and click the plus sign, then I click the 3, it needs to remember that I previously clicked the plus sign, and then before that I clicked the 7. So very quickly, we're seeing that our program is going to need to remember things. And in programming, when we need to remember something, we usually create what are called variables. Right? And variables, I'm not talking about like solve for X, solve for Y. Variables are basically setting aside a little memory so that our program can store some piece of information. And that information might be a number. It might be, in App Inventor, it could be a color. It could be text. It could be all sorts of information. But whenever we want to hang on to something, we have to create a variable to do that. So in App Inventor, we can create variables. Right? On the left-hand side here, it's in orange. It says variables. If we click on that, you're going to see 5 different blocks. Initialize global, get, set, and then 2 different initialize local variables. For this program, we're only going to be using global variables. And when a variable is global, it means that you can use it anywhere in your program, anywhere in your app. When it's local, you can only use it in a very specific section. So global, think about the whole planet. You can use it anywhere. Local, you're more confined in where you can use it. So we're going to be using global variables for this first app. And we're actually going to be using 3 of them. So what I'm going to do is I'm going to drag this in. And then you can either keep dragging it in, or if you right click on a block, there is a duplicate option. So I'm going to hit duplicate twice and get these 3 blocks. And much like I wanted to give my objects names that referred to what they were doing, I'm also going to give these names. So I'm going to call this first one numbers. because it's going to hold numbers. I'm going to call this second one operation, because it's going to hold what operation we picked. And then I'm going to call this last one hold, because we're going to use it kind of like to temporarily hold things. All right, so again, I'm giving them three names that sort of relate to what they do. And then when we initialize, that's another way of saying create the variable, we also want to give it a starting value. And for these, I'm just going to set them all to 0. And again, I could keep dragging zeros over. I could right click and hit duplicate. Also, if I type 0, or if I type anything that's a block that already exists, so like if I type if, you'll see that I get this kind of drop-down menu, and I can use this menu to get the block that I'm looking for without actually having to keep dragging it over and over and over again. So if you really want to type out your code, you can always type it out, the menu will pop up, and then you just click on it, and it'll bring it over for you. So I could be like, oh, there's my 0, there it is, and I've initialized these three variables to 0. So these are the variables that are going to hold on to the information in my app. All right. So next, let's talk about the number keys. All right. We've got to set up these number keys so that as people type in numbers, it sort of stores the number that they've typed in. Now, this might seem kind of trivial, but it's actually a little trickier than you might first think. Right? Because let's say I want to store the number, let's say I hit a 1. Okay, so I hit 1 on the screen. I might be like, all right, time to store 1 in my variable. But the program doesn't know whether the user intends to just press 1, or are they pressing 1 and then are they going to follow that up with a 2 because they actually want the number 12? And then once they type in the 2, again, the program doesn't know if the user is done. Maybe the user actually wants to type in a third number and they're going to want the number 123. So when they hit 1, I can start by storing 1, right? That part is easy. But then, depending on what they hit next, I might have to do something different. Like, if they follow that 1 up with a plus sign, then I'm good. I stored the 1. But if they follow that 1 up with a 2, I actually need to find a way to turn that 1 into a 12. And then if they stop at 12 and hit a plus sign, I'm good. But if they go on and hit 3, I actually need to find a way to turn that 12 into 123, right? So to do this, we're going to have to be a little clever. And that's a big part of programming, all right? It's trying to figure out how to take something that we know how to do and put it in a format that a computer can handle and understand. Because for us, this is pretty trivial, all right? We just write out the number. But for a computer, it's a little trickier because we have to do it step by step by step and say, all right, first we store the 1, then we turn the 1 into a 12, then we turn the 12 into 123. All right, so the question is, how can we do that? All right, now, if you were in class with me right now, we'd kind of try to brainstorm ideas and come up with a solution. And it wouldn't be a bad idea for you to pause this right now and think about it. Like, how can we make this happen? All right, so the way that we're actually going to do it, I hope you paused it and give it some thought. Maybe you've got an idea. And sometimes kids say, oh, well, let's add 11. And then let's add 111 and so on and so forth to get it. But the problem is you're adding like different numbers each time, and depending on which number they hit, you have to add different things. We want to come up with like one basic rule that will work no matter what. So the way that this is actually going to play out is, let me erase some of this here so that I've got some more room. make this a big eraser, or select. There we go. That's probably the quickest way to do it. All right. So 12 could be rewritten as 10 plus 2. All right, so I could rewrite this 12 here as 10. Actually, let me go to the paintbrush. I could rewrite this as 10 plus 2. And I could rewrite 123 as 120 plus 3. And I could actually rewrite 1. I don't know why I would want to do this, but I could rewrite 1 as 0 plus 1. Now, let's imagine our user is typing in 1, 2, 3 here, and then you'll see kind of why I did this. All right, so if they typed in 0, if they typed in the first digit 1, I could just add 1, and then I've got the number that I want. 0 plus 1 is going to be 1. If I start everything at 0, 0 plus 1 is going to be 1. Now, when they type in the 2, I want to do 10 plus 2. Well, how can I turn a 1 into a 10? I could add 9, yes, but I could also multiply it by 10. So if I take whatever this number was, multiply it by 10, and add 2, that'll get me a 12. Now, how can I get 12 and turn it into 120? Well, I could take 12, multiply it by 10. That'll give me 120. And then I could add 3. And what you'll notice is, in both cases, I was doing the same thing. I was multiplying by 10. I'm basically shifting the decimal point one spot to the right when I multiply by 10, and then I'm adding the digit that they just typed in. All right? And again, you didn't need to figure that out by yourself, but that's showing you a little bit of what computer science involves. It's how do I make the computer do an everyday task in a language it can understand? So when we write the code for this, what we're going to do is we're going to take whatever number they typed in previously, we're going to multiply it by 10, and then we're going to add the current number. And let's see if this works. All right, so I'm going to go to num1 here. I'm going to get the yellow event when num1 clicked. All right, so I've got this yellow event when num1 clicked. And what I'm going to do is I'm going to set my variable, because remember, our variable is where we keep track of information. So I'm going to set my variable. Now, when you drag the set block in, it's empty, but then you click on this drop-down box, and I'm going to set my variable numbers, and then I'm going to go into the math menu, and I'm going to get an addition block, and I'm going to get a multiplication block that I put right inside of that first part of the addition block. So what I'm going to do is I'm going to say take whatever the number used to be. So if I want to know what it used to be, that's going to be a get block. And I'm going to say take whatever numbers used to be, multiply it by 10. So I'm going to get a numbers block, change that 0 to a 10. And then I'm going to add whatever button they pressed. And since this was button 1, I'm going to add 1. So here's my event when number 1 is clicked. When that is clicked, I'm taking this variable that starts at 0. I'm multiplying it by 10, so 0 times 10 is 0. And then I'm adding 1. 0 plus 1 is 1. All right, so now this variable, instead of having a 0 in it, has a 1 in it. If I were to press the button again, it would be doing 1 times 10, which would be 10, adding 1 to that, which would give me the 11. If I were to press it again, it would do 11 times 10, give me 110, and then I would add 1 to it. So multiplying by 10 just keeps sliding the decimal spot one spot to the right. It kind of gives you an open spot. and then whatever button they pressed, you kind of slide into that open spot. Now, here's another important principle in computer science. If you want something to happen, you have to tell it to happen. Now, why is that relevant here? So we just did this calculation. We changed the variable, but that does not change our app. All right, it does not change what's on the screen of the app. If I want the screen to change, I have to tell the screen to change. So the output is that label that we set up. Again, I called mine display. If I click on display here, I'm going to get the dark green block that says set text. Now, shortcut, you can actually get any dark green block and then use the drop-down box to change what you want. But I'm going to set it to text. And whatever number is now being stored in this variable, I am going to plug it into that dark green block. So I'm going to do get numbers, and that's going to set the display window to whatever number I just typed in. So if I hit a 1, now my app shows a 1. If I hit it again, it shows an 11. If I hit it again, it shows 111. If I hit the 2 key, nothing happens because I haven't written the code for that yet. All right, so again, you are responsible for everything. Now, good news on the rest of these keys is that there is a duplicate feature when you're coding. There isn't when you're like making the buttons, but there is when you're coding. So what we can do at this point is we can take our event here, we can right click on it, we can choose duplicate. Now it makes a duplicate and they have a red X. The reason it has a red X is because you can't have two of the same events. All right, right now this is saying when num1 clicked, do this. This is saying when num1 clicked, do this. You can't have two of the same events because then the program doesn't know which one to run. So what we do now is we click on this drop down and change it from num1 to num2. And then instead of adding 1, we're adding 2. All right. Everything else stays the same. We're still multiplying by 10. We're still changing the text. It's just now we're adding 2. And then I'm just going to keep going down and doing this for all of my keys. So just give me a second. You can be doing the same thing here, but I'm just going through one by one. I'm changing the drop down and then I'm changing the number. And I would recommend just doing them one at a time, because if you try to like duplicate a whole bunch at once, it just becomes tricky to sort of keep track of everything. And see, like, and if you ever see the red X, it means you forgot to change it. So like I almost forgot to change this one. So let me just keep going down. Num7. Okay, duplicate. Num8. We're going to add 8 there. Duplicate one more time. We're going to add 9. And then let me change this to 9. And then duplicate one more time for the 0. Now, with the num0, we could change this to 0, and that'll work. But then you're also making it do an addition that it doesn't have to do, because adding 0 obviously isn't going to change it. So I'm just going to pull out the times 10, because that's the part that I need. I'm going to throw away the addition, and I'm just going to say global numbers times 10. All right, if you leave the plus 0, it'll still work. You're just making it add 0 when it doesn't need to. Now, you'll see here, I've got all of these. They're all set up there. And now if I go to my emulator, all right, no matter which number key I press, it should put in the right number. And you should take a second to press every single button to make sure that you didn't miss one or goof something up. All right, so all of mine seem to check out. So that's good. And at this point, I might want to work on the clear button, right? Because I just did all that testing. I've got all those numbers in there. It might be helpful to be able to clear those out so that we can get rid of them. Now, for the clear button, we're still going to go to this menu here. We're going to click on clear. It's still going to just be when they click it. And when we hit clear, what we're going to do is we're going to set all the variables back to 0, which was their starting value. And then we're going to set the display text to 0 as well. So we're basically going to clear out the computer's memory by setting everything back to 0. And then we're also going to change the text to 0. So I can go to variables. I can get 3 set blocks. So I'm just going to duplicate this. I'm going to set them to my 3 different variables. And then I'm going to set them all to 0. So I'm actually just going to get one of these zeros, duplicate it, and duplicate it. So that clears out the variables, but it doesn't clear out the screen. Remember, if you want to do something, you have to write the code that does it. So I'm going to go back here. I'll just take this one right here. I set the variables to 0, so I can take this, I can duplicate it, and it'll clear it out. Now, if you're going to do it this way, where I say set display text to global numbers, you have to make sure this is at the bottom. All right? It's going to run this program from top to bottom. So if you did it in this order, it wouldn't work because you're setting the variable to 0 after you've changed the text. So you got to make sure that this is above this so that it first sets it to 0 and then changes the actual text on the screen. But now I should have a function clear button. All right, so that's good right there. So I've got these. I can type in my different numbers. I can hit clear. It wipes it away. We're almost there. All right, so we've got our buttons working, our number buttons working. We've got our clear button working. All right, so next, let's do our plus, minus, multiplication, division. So again, these are all going to be kind of similar. So we'll do one, and then we'll kind of copy it and go from there. Now, one thing I want to show you, your screen can start getting sort of crowded. What you can do is if you right-click in the white, there's an option to collapse blocks. That will collapse all of them, basically make them smaller. If you only want to collapse one of them, you can right-click on the event itself and choose collapse. But it can be helpful to just keep things neater. So I can go collapse blocks, and then all of these become much smaller, and they take up less room. Like I already know that they work. Like I've checked them, I've tested them. So I can collapse them now and then put them all up here so that my program is a little more condensed. You don't have to do this, but some kids like to do it and they like to know how to do it. So I'm just kind of showing you this quickly here so that you can see how this would work. And again, instead of scrolling, I could also zoom out and then be like, oh, there's this one. And then once I'm ready to work again, oh, there's this one, zoom back in. So you get used to this. It can be like a little cumbersome at first, but then once you get used to it, you can work pretty quickly in it. And then again, if you want to expand one, you can right-click on each individual one and expand it. Or if you right-click here, we can expand blocks, and that will expand everything. There's also like arrange blocks horizontally, arrange blocks vertically. This will just line things up in sort of a neater fashion if you want to do that. So if you're somebody that likes to have things very organized, this is a way that you can do that. All right. So there's all my program so far. All right. So next, let's get to the plus sign. All right. So they've just typed in their number. And now we have to get ready to figure out what operation they want to do. So if they click on the plus sign, there's my event when the plus button is clicked on. What we're going to need to do is we're going to need to save the first number that they typed in. All right. And you might be saying to yourself, well, we already typed it. We already saved it. It's already in this numbers thing. Yeah, but we're going to have to move it over to hold. And here's the reason why. These buttons all work with this variable. So when the user gets ready to type in their second number, it's going to erase what's ever in here to start typing in the second number. So that means if we want to be able to do it as part of our calculation, 1 plus 2, 1 plus 2, once they start typing in this 2, we have to make sure that we don't lose this initial 1 that they typed in. So the very first thing we do when somebody clicks the plus sign is we're going to save that previous number that they typed in. So the way we're going to do that is we're going to say set hold, and that's why it's called hold. We're like temporarily holding it. We're going to set hold to whatever is currently inside of numbers. So if somebody had typed in an 18, we're taking that 18 and we're basically copying it over into hold. And then we're setting numbers back to 0 so that it's ready to get the next number. All right, so we're basically saying, hey, we got to get ready to get the next number. So set this back to 0. We're going to set the screen back to 0. So I'm going to say set display text. And I could either hard code in the 0, or I prefer to use the variables. Generally, you want to avoid hard coding things into programs as much as possible. We'll talk about that why in the later class. But right now, I'm just going to say set display text back to numbers. And since I set numbers to 0, that'll change it back to 0. And then I'm going to set operation, which is our variable, to 1. All right. I can't actually do the addition yet because I don't know the second number. So what I'm doing is I'm setting this variable to 1. 1 is going to represent addition. 2 is going to represent subtraction. 3 is going to be multiplication. 4 is going to be division. So once I've got this done, I can right click and choose duplicate. And I'm going to do drop down and I'm going to change this to minus. And the only thing I need to change is I need to change operation to 2. And then I'm going to right click and duplicate it again. And all I need to change is multiplication and change this to 3. And then I'm going to hit duplicate again. And I'm going to change this to division. And again, just be aware that if you named your buttons differently than me, you might not have div, you might have spelled out division, but it's the same thing. You've just got to find the one that matches up. So now I've got these, and they all do the same thing. They take whatever number was there, and they save it inside of hold so that we keep track of it, because we need to keep track of everything. We reset this to 0. We change the text so that it shows up as 0 on the calculator, and then we save which operation we picked. So if we go back to our calculator here, all right, when I hit plus, I should see a 0 here because it's now ready to get that next number. All right, so and then if I hit minus, it goes back to 0. If I hit times, it goes back to 0. If I hit division, it goes back to 0. All right, so we're almost there. We've only got one step left. And that's our equal sign. So I'm going to condense these down so that they're out of the way. And then I'm going to arrange them horizontally. And now we're going to do the very last block, which is the equals block. So I'm going to go over here. I'm going to go to equals. And I'm going to say when I click on the equal button. And this is where we get to our next sort of big concept of the day. So the first big concept was, well, there's a few big concepts, let's be honest. One is this idea of events, and we use events to trigger code. 2 was this idea of variables, right? Anytime we want to remember something in a program, we're going to have to create a variable to remember that piece of information. And then the third piece is going to be how we get computers to make decisions. All right. And the way we get computers to make decisions is something called an if statement. All right. And an if statement basically says, if one thing is true, do this. Otherwise, don't do it. So if I drag in this if statement here, this is basically saying, hey, if whatever I put up here is true, so like are roses red? If roses are red, then we would do the code that's down inside of here. If roses are not red, then we would skip this code and continue on to what was ever after this. So we're going to use this to figure out what we're actually supposed to do. So if you remember, we have this variable operation that lets us know what the user chose. Did they choose addition, subtraction, multiplication, or division? So inside of here, we're going to say if, and then we can either go to the logic menu, which has an equal sign. It has an equal sign and a not equal sign. Or we can go to the math menu, and this one has an equal sign, a not equal to, a less than or equal to, a greater than or equal to. Because we're just doing equal, either one is going to work. But we're going to take this and we're going to say if our operations variable is equal to 1. Because remember, we either set it to 1, 2, 3, or 4. 1 was for addition, 2 was for subtraction, 3 was for multiplication, 4 was for division. So we're saying if that variable has a 1 in it, now we know that we need to add our two numbers together. So we're going to add those two numbers together, and we're going to say set our numbers variable. All right, we're going to use the numbers variable here. 2, and then we're going to do get hold. So that was the first number they typed in, plus get numbers, which is the second number that they typed in. All right, so basically what we're saying is they typed in the first number, that got put into hold. They typed in the second number, that's what's currently in numbers. So we're taking hold and we're adding it to what's already there to get our new answer. All right, so if it's 1, we're going to add. Now, if you notice, this if statement has a little gear next to it. So if we click on that gear, what it lets us do is extend the if statement. All right, we can add what's called an else if or an else. So if I take this else if block and I don't drag it down here to the main section, I use this little window that pops up on the side. And when I drag it in there, you'll notice that the main block gets another plug. So what I'm going to do is I'm going to plug the same thing in here. I'm going to do an equal sign. I'm going to do global operation, but this time I'm going to do the number 2. And the way that a computer looks at this is it goes and checks to see if the first thing is true. If it's true, it runs this code and then it skips everything else. It doesn't look at this here at all. It just totally skips it. All right? If it's not true, if this is not true, then it goes and checks this next piece here. All right? And says, oh, is global operation 2? Now, if it is 2, then we're going to do subtraction. So again, we're going to go to set global numbers. This time we're going to get a subtraction block. All right, so we can't really duplicate this one because we have to get a different block each time. Now with subtraction, the order matters. So make sure that you put hold first because that's the first number they typed in, minus numbers, which is the second number that they typed in. All right, so now we can say if it's a 1, we know to add the numbers. If not, let's check to see if it's a 2. Then we're going to subtract the numbers. And then we can go to, we go to the gear again. Drag in another else if. And we can say, all right, else if equal sign. If the operation value equals 3, then we're going to multiply. Right, so again, same kind of process over and over again. So I'm going to set global numbers. This time I'm going to get a multiplication block. Now multiplication's commutative, so the order doesn't matter, but I would still do hold first because that is the first number they typed in. I would do numbers second, and then we can go here. We can do another else if, and we can say, all right, let's get our equal sign. If the global operation equals 4, we can do that. And then we can change set numbers to a division block. And then global hold. Whoops, did not mean to do that. Global hold, global numbers, and then I'm just going to delete this block here. So now I'm saying if it's 1, add the two numbers together. Else if it's 2, subtract the numbers. Else if it's 3, multiply the numbers. Else if it's 4, divide the numbers. Now, you might have also noticed when I clicked on that, there was an else. You can only ever have a single else, and it goes at the very bottom. So I can't put in multiple else's. Right? If I try to, it's just not going to work. The other one is going to pop out because you can only ever have one else. The else is like your default. So if this isn't true, and this isn't true, and this isn't true, and this isn't true, then this is the code that you run. All right? You're not required to have an else. Like for us, if they didn't hit plus, minus, multiplication or division, we just don't want to do anything. So we're not actually going to have an else. We're going to get rid of this, and I'm going to show you how to do that in a second. But that's what the else is. It's like the default, like if nothing else, if none of these other things are true, then we at least run the code that's in the bottom here. So to get rid of that, you would just click back on the grid, and then take this else and just drag it off to the left, and then it'll disappear on the main block. So this right here is going to carry out the operation. Now, remember, it changes the variable, but we also have to change the screen. So we're going to go to display. We're going to say set text. We're going to set it to that variable numbers because, again, that's what's holding our answer. That's where we put the answer. So we're going to say get numbers. And then what we're going to do is we're going to clear out that operation variable, all right? Because we don't want, if they keep hitting equal, it would like run this code over and over and over again. But we only want it to run the code when they've actually picked an operation. So we're going to set this back to 0 because now if they hit the equal button again, none of these will be true. It won't equal 1, it won't equal 2, it won't equal 3, it won't equal 4. So it just won't do anything, which is kind of what we want. We don't want it doing anything because the user didn't actually pick what it wanted it to do. So let's see where this leaves us. If I do 12 plus 5, and then I hit the equal button, all right, I got 60. All right, so either I just hit the wrong button and didn't realize it, or we have a bug in our code. Let's figure out what it was. All right, 12 plus 5 equals 17. I just must have hit the wrong key and not realized it. All right, 4 times 7 equals 28. That's good. Let's see, 20 divided by 2 equals 10. All right, did I test everyone? I don't think I did subtraction. 4 minus 6 equals -2. All right, great. So you're seeing that we've got a little calculator. Now, is this calculator perfect? No, not even close, all right? If you play with this calculator enough, you're gonna see that it does some really weird things, all right? Like if I were to hit 8 right now, it would take my -2 and turn it into a -12. And you're saying to yourself, why did it change -2 into 12? Well, because of the way we wrote our program, all right? We said multiply the number by 10 and then add whatever digit they typed in. So we did -2 times 10. That became -20. We added 8 and we got -12. So what we're seeing here is that if we wanted even a halfway decent calculator, we'd have to pay attention to whether the number was positive or negative, because depending on whether the number is positive or negative is going to depend on whether this code works, right? And this might work for positive numbers, but we can see that it's not going to work for negative numbers. All right, there's also the weird thing of when I get my answer, so let me clear this out. If I do 10 plus 2 and I get 12 as my answer, if I start typing, it doesn't clear out the 12. It just says, okay, 12 is now 123, which is now 1,234. So maybe we have to put in code that like clears things out after we do a calculation. So we could go down a giant rabbit hole here, making our calculator more sophisticated, but we're not going to, all right? This sort of gives you a brief introduction to MIT App Inventor. It shows you how some of the coding works, and it introduces us to this idea of variables and if statements, which are two things that you're going to have to set up and use when you do your first lab, all right? So this is kind of giving you some familiarity with this stuff, so that when you're ready, so that when you try that first lab, it's not all brand new, all right? So in that first lab, you're going to be creating events. You're going to be changing properties. You are going to be creating variables. You are going to use an if statement. So no, our app is not perfect, but it's going to served the purpose of what we were looking for. It introduced you to some of these things. It showed you how to use this interface. And then going forward, you'll get to start trying some of this on your own. It won't be me walking you through the entire app. That was pretty much today only. It'll be you practicing and trying and figuring out this stuff on your own. So again, I hope this was helpful. Let me know if you have any questions, and best of luck. All right.